So the first sorting method that we went through was insertion sort. So again, like we said before, insertion sort tries to figure out where the first element in the unsorted portion of the array goes in the sorted portion of the array. So here we have some unsorted array, right? And initially everything is in the unsorted part. And what our algorithm here says is for every element in the array, so going from 1 to the length, we're going to insert array I into array I from 0 to I minus 1. So one of the questions is, why does it start at 1 and not 0? Well, again, that goes back to our base case. An array of one item is already sorted, right? So 15, if it's in an array of its own, is already sorted. So now, when I is equal to 1, we're looking at 7, and we want to know where 7 goes. Where does 7 go in this array of just 15? Right? Because remember, our sorted array is 15, and we want to know, where does 7 go? Well, 7 goes before 15, right? So we're going to insert it here, right? And then in that case, we're going to have to shift 15 down. And that's exactly what we do. So now our sorted array is 7 and 15. And we want to know, right? So it's 7 and 15. And we want to know, where does 3 go? Well, we can see that 3 needs to go right there, right? And in this case, we're going to have to move 15 down, 7 down, and put 3 at the beginning. We do the same thing with 8, right? And we know 8 needs to go, so 8 needs to go here, right? So if 8 goes here, then 15 needs to go there, right? Same thing with, so 18 is already in place, so we really don't have to do anything. And then 12, we know it needs to go here, it needs to go here, which means 15 needs to go there, and 18 needs to be moved. And then finally with the 2, we're going to bring the 2 all the way to the beginning, and we're going to shift everything down by 1. And there we go. Now our entire array is sorted, right? Because we got to I is less than array length minus 1, and we can stop, right? We know we now put everything in the place where it should be. So what's the actual algorithm look like? Well, here it is, right? We're going to go from I equals 1 to array.length minus 1, and we're going to insert array I into 0 to I minus 1. So we're going to initially start with our index at the last location. So starting from here, we're going to keep going back, right? And we're going to save the element, right? That last guy, we're going to save this guy somewhere so that we can start overwriting it when we find the right place. So then we're going to keep decrementing index, right? As long as it hasn't reached the beginning, and while it's still bigger than the thing that we need to add. So we're trying to find the location where we need to insert element. And then once we find it, the element should be at index. And then we're going to move everything from index plus 1 over by 1, right? We're shifting it. So starting at the end, we're putting, so J starts at I, right? So that's saying, we drew it here. as shifting 3 to 7 and then 7 to 8. But really, we're starting at the end. So we save, right? 1 is save 3. And then 2 is shift. Right, so we do this one first. And we know we can overwrite this because it's already saved somewhere. Should be 2. And we know we can do this because we've already saved 18 there. And that's it. We keep doing it until we've inserted everything into our array. So the question is, what's the running time of this guy, right? Well, we have inside this outer for loop, so we know this outer for loop runs O of n times. And inside, well, we have some stuff that runs in constant time. And this while loop, which could run up to I times. So that could be O of I. And then this guy runs as many times as this guy. So this is also O of I. So that means, what is our actual running time? It looks like I did some of this already. Our running time turns out to be this sum where, we're doing 2 times n, right, when I is equal to n, and then 2 times n minus 1 plus 2 times n minus 2 plus blah, 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 and that ends up being O of n squared. Right? So this sum comes up a lot, right? Oh, geez. Sorry. This sum comes up a lot in what we're going to see, right? Where you're running an outer loop that we know how many times it runs, and then the inside loops depend on what the value of the outside loop is. And in most cases, that turns out to be n squared.